I read a book a while ago written by David Marr, who was the kind of father of computer vision and computational neuroscience together. So he really married those two fields. He did work at MIT in the 70s, and there was a lot of work being done at the time to look at how human vision works. So, how how's that first layer of glial cells with retinol convert, or do like very basic signal processing, and and then further back in the brain, how's the V1 part of the visual cortex do X and Y, and his notion was that, okay, well, we can take these little slices that we understand and actually glue them together and put it and simulate it in a computer. And so computer vision was born out of trying to understand what the human visual system was like. And so it was kind of a natural product of that process, and then it became its own field unto itself. But I'm sure there's other instances where language processing, for example, we try to do, or there's a lot of research put into how a computer can process language. So that kind of immediately raises the question, well, should we do it like a human? And what does the solution space look like?
Yeah, I think a lot of a lot of the solutions are about goals. Like, what is so a lot of early research into computer vision was about text recognition, not computer vision like making computers see like a person, but identify things that we might find useful to identify. And not text recognition in the OCR sense, which is again getting us back to Kurzweil, but like in a sort of like in the 1950s sort of context. But now, one of the famously Marvin Minsky, assigned some graduate students in the 1960s to over the weekend solve for a program that could teach wherein a computer could identify a particular object in a picture, right? And he thought it would be like this super easy thing to do, and it's still something we can't do. It's because we want to model the like human dimension of it, as opposed to sort of boiling down the world into a particular set of primitives, and then identify those primitives because we've built a computer that only cares about those particular things. Which I think is also this question of simulation. It's like, are we simulating what we understand about ourselves and then allowing the computer to...
Totally. Like the task itself is almost anthropomorphized. Like vision, if you're trying to get a computer to understand or process vision or understand or process text, our notion of vision and of language is embedded in what a human is.
And just coming back to like simulations and hierarchy simulations, you can certainly divorce different levels, right? You don't need to know, you don't need to model quantum mechanics if you're dealing with like population genetics, right? So you have certain separations. But like this might be a little aside, but going back to simulations, like just as a biologist, like you look at certain tipping points in life's evolution here and which way it can go, right? And the constraints, the solution space. things were fine for a long time, billions of years, with single-celled organisms. Then you had this event happen 600 million years ago that led to multicellularity, right? There had to been. Is there something you can simulate to why then, why now, why, because we still live with microbes. They're fine. They're completely, they're very competitive. They take up the bulk of the ecosystem. But, why would you need multicellularity? And could you even model that? You just take it for granted that it just happened.
Yeah. I think that the thing that's interesting to me is that the way that computation functions, at the most basic level, right? We were talking earlier about procedural knowledge versus other forms of knowledge, or procedural computation versus other forms of computation. But the idea that you have to account for things in advance in order for them to be computable, and you can create random events by giving them a probability, certainly. But is that the same thing as the kind of randomness that allows for mutation in a biological sense? I think is sort of different, and that's also something that Turing really struggled with, was what is outside of procedural knowledge, and does that mean it's outside of computation? If it's outside of computation, is it outside of computational simulation? Yeah, it's not like just a computer's rolling dice, and then once every 600 million years, multicellularity happens. That's not an accurate model. And that sort of why question. I think a lot of things we're talking about seem like they are you guys familiar with the concept of hyper objects?
Heard about it a little bit. You're
Not
probably
really.
gonna have to give
No.
me a bit of a primer.
It's I think it's Timothy Morton. A bunch of people have written about it, but it's this idea that certain kinds of objects exist on a scale such that they are unknowable. As an individual, you can't conceptually understand them, and that makes them particularly problematic. So the most obvious example is a kind of ecological one. It'd be something like climate change. You can't individually, maybe intellectually, you can understand that climate change is happening, but because you can't experience climate change because it is a process that takes hundreds or thousands of years, and it's something that's global in the way that the climate interacts with itself. Even modeling the climate in general is still very difficult to do computationally, and it was one of the first things that people tried to do. So hyperobjects sort of exist on a scale beyond us, and so they are not, in the way that you're talking about, if you can build it, you can know it, that certain things seem unknowable in that they are exist beyond that particular scale. And I think simulation gets us sort of close to those things, but it involves a degree of knowledge about the world that at this point seems almost impossible. Though at the same time, technical things can be hyperobjects. The internet is arguably a hyperobject because, while we understand how it works and we built it, it escapes us in its entirety because it's every website, every email, every cable, everything. And so it's an interesting theory because it talks about the sort of unknowability of certain kinds of non-human actors, but it's frustrating because I think the way that we've been trying to describe this stuff is about how to get closer to knowing it, right? And which is maybe a kind of hubris.